Hey everyone, welcome to Hexport Labs. This is a channel dedicated to sharing technical and IT security focused content with the practical demonstrations and the deep dive knowledge. In the very first video of this channel, we are kicking things off with the Linux special permissions. These are the sticky bit and the set user ID bit or the SUID bit and the set group ID bit or the SGID bit. Now let's take a look at my notes to see what they mean, and later on we're also going to make some demonstrations on my curly virtual machine. Before we dive into the Linux special permission, I just want to make a quick recap about the Linux regular permission. So every file or directory or the system binary in Linux, they have their own permission. Basically, we have read, write, and execute, and photo on one with a numerical value respectively. So we can change the permission with the chmod command, but in two ways, with the numerical value and also the UGO. UGO simply means U for the user or the owner, G for the group, and O for the others. So we can set it like chmod and 644 and the file name as an argument. So we have 6 for the owner and the fo for the group and the fo for the others. So we have 6 mean fo plus 2 that the read and write permission is given to the owner, and the fo mean the read permission is given to the group, and also fo means that the read permission has given to the others. In the case of the UGO, G minus R means that R means the read permission, so that G means the group. So we're not giving the read permission to the group. When we like to give the read permission to the group, we simply set G plus R file name, so we're giving the read permission to the group now. Similarly, we have read, write, and execute permission is given to the user or the owner, and the read and execute for the group, and the execute for the other with a numerical value. We can set it like chmod, and read, write, execute 4 plus 2 plus 1 is 7, and the read and execute is 5, and the execute is 1, and a file name. So we also have some example for a file and a directory, and the file is denoted by dash, and the directory is denoted by D. We have rw dash here, and also it's for the owner. Rw dash is for the owner, and that r dash dash is for the group, and that rw dash is for the others. So rw dash means we have given the read and write permission, but not the execute permission to the owner, and the read and just the read permission, but not the write and execute permission to the group, and only the read and write permission to the others. That numerical value, when is the link count, it simply means the number of hard links to the directory or file. And that is the owner of the file, and it's the group associated with the file. The 7 is the file size, and the December 25, 831 is the last modified date of the file, and that is the file name. So the same concept applied to that directory. Now let's dive into the Linux special permission. In the special permission, we have three things: sticky bit, and the set user ID or the SUID, and the set group ID or the SGID. So let's take a look at set sticky bit. Sticky bit actually prevent the unauthorized deletion in shared directories. So let me give you an example. So when we create a file with the name vulnerabilities here, when I created a file with the name vulnerabilities and that group associated with the directory would be the group name with the we hackers. So it would be like that. It would be like that. This is the directory name, and that is the associated group. So the member of this group, we hackers, will have the permission to modify or delete the contents of the file within the directory. So without the sticky bit, let's say in the group we hackers, they're the users or the members called Steven and the Edward. So when Steven created a content within the vulnerabilities directory, maybe the Edward would be able to modify it or delete it. So Steven wouldn't be happy with that. So this poses security concern, as any member can alter or remove files that they do not own. But in Linux, when we set the sticky bit on a directory, only the owner of a file or the directory can delete or modify it. Like the example, Steven create a file but the Edward wouldn't be able to modify or delete it because we have set the sticky bit on that directory called vulnerabilities. So sticky bit also has a fixed value of 1000, where the UGO is going to be T, and the permission of the file and the numerical value would be 1644. So let me explain it. It's just going to add 1000, which is the sticky bit value, plus, let's say we have in this case 644. So 1000 plus 644 is equal to 1644. So I would like to give you an example on my some demonstrations on my Kali virtual machine. And in this scenario, we are going to have a group called We Hackers, and the group members of that group We Hackers would be Stephen and Edward, and the directory name would be vulnerabilities. So in this example, the permission of the group We Hackers to the directory vulnerabilities would be the RWX or the full permission. In this case, it would be like that, exactly like that. And without the sticky bit, all the group members, in this case, Stephen and Edward, can modify and delete any file in the directory, even if they did not own or even didn't even if they didn't create it. So now let's hop up to my Kali virtual machine and take a look at the demonstration of the sticky bit. So let's say now we're going to add a group so we're going to type the command group add. The name is We Hackers. Now we're going to add some user to it. User mod -ag, and to the We Hackers group. We Hackers group, the user Steven. I've already created that user Steven. So Steven and again Edward. I also already created Edward. So these are the two users, and we can check it like cat etc group. So we can see that group We Hackers, and the members are Stephen and Edward. So now we're going to create the directory vulnerabilities. Okay, and we are going to give the permission of that group. So ls -hal, we can see the vulnerability directory, the associated group is true. So now we're going to give that to the We Hackers, chgrp We Hackers to the vulnerabilities. ls -hal, we can see now that the associated group is We Hackers. And also we are going to give the full permission for the We Hackers group. So maybe 777 to We Hack 777 to the vulnerabilities, and cd/. Now we can see the group associated with We Hackers and the read, write, and execute. So 777. So to be play around with the multiple users in the /root directory, which is the home directory of the root user, we must give that permission to the others. We must give the full permission for the others. So chmod 707. That's not the security best practice, but that's for the demonstration. I'm just going to do it. Root. So the other user have the full permission on it. So now what we're going to do is root and vulnerabilities, and we're going to switch user to maybe Stephen. Yeah, Stephen. So Steven is now in the /root and vulnerabilities directory, and so we're going to make something echo Steven created it to the Steven.txt. So list that out, cat that out. So Steven created it, and Steven exits. And we're going to switch to Edward. So Edward's going to list out, so Steven, so he can see that. So he cat this out, so Steven created, but he want to delete it. But for sure he want to delete it, but for sure Steven won't be happy about that. So he rm and Steven.txt. Edward delete the file that created by Steven. So he delete it, enter. So remove it protected. So we use yes. So it has removed successfully. When we list out, it's nothing here. So exit. When we switch user to Steven again, Steven lists out, it's gone. So Steven wouldn't be happy with that case. So what we're going to do now is to protect this case, we're going to set the sticky bit on that directory vulnerabilities. So when we list out, let's minus HL. Okay. We are going to add chmod, and instead of 777 vulnerabilities, I have said that we have the fixed value of 1000. So 1000 plus 777 is 1777. So we have set it. So when we cd dot slash, what is ls, we can see rwx, rwx, and rwt. Instead of x, we have t because we have set the sticky bit. So when we switch user to Steven again and cd to vulnerabilities, and we create it again, echo Steven created it again. So Steven.txt. So Steven created it again. So he cat this out. So he can see that Steven created it again. So we exit, and switch user to Edward. And cd to vulnerabilities and list out, so he can see Steven. So he's going to read it again. He can see that Steven created it again. So Edward can see it. So Edward tried to remove it again. Remove Steven.txt and hit enter. So hit yes again. So let's see, operation not permitted. So we have successfully set the sticky bit on the vulnerabilities directory. So that is about the sticky bit. It prevents the unauthorized deletion in the shared directories. So let's going to look at the SGID bit. The SGID bit, and it also has the numerical value of 2000. With the UGO, we have the value for the SGID bit is S. So example, when we set with the numerical value, it would be 2644 because we have add 2000 plus 644. 2000 is the SGID bit, 644 is the regular permission, so 2644. For the sticky bit, it ensures that all the new files in the subdirectory is created within inherit the group ownership of that directory instead of user's primary groups. I think you haven't got any clue with what I've said by listening that definition, but don't worry, you will get completely from the demonstration. So SGID bit on the executable files, it allowed the file to run with the permission of its group owner rather than the permission of the user who executed. So let's take a look at my Kali. So we have created the vulnerabilities directory. So let's exit and let's create some context within it. So vulnerabilities, and we're going to create something to ch touch and something like root created.txt and switch user to Edward and touch Edward created.txt, and we're going to exit and also to see switch user to Steven and Steven touch Steven created.txt. So when we list out, we can see multiple Edward created and the root created and the Steven created. So when we see that the group associated when Edward created it is the group associated is Edward. So when root created it, the root associated is the root. When Steven created it, the group associated Steven. So that's the scenario before we set in the SGID bit. So let's set the SGID bit to that directory, vulnerabilities directory. So we exit and this cd dot slash and c chmod with, instead of 777 we now want to set the 277, or we can set also 3, because in the case we have sticky bit has 1000 and the SGID bit had 2000, so we're going to add that two things. So 2000 plus 1000 is 3000, and 777 we can add the 377. That's going to be put sticky bit and the SGID. So in this case we're just going to add the 277, just the SGID bit, or maybe sticky bit if you like, and to the vulnerabilities. Okay, let's list that out. So we can see RWX, RWS, and the RW instead of X we have S. So now let's create something like touch and root created again .txt, switch user to Edward. So touch Edward created again .txt, exit and switch user to Steven, cd2 vulnerabilities, and list app for make sure. So Edward created, so we're not going to TOUC touch Steven created again .txt. So by mistake we haven't created the vulnerabilities directory, so we're going to create it again. cd2 vulnerabilities and touch root created again .txt and switch user to Edward touch Edward created again .txt. So now exit and let's take a look at ls minus HAL. So here's Edward created again, Edward root created again, and the Steven created again. So when we look at this, even the Steven created again, the group associated with hackers now. When the root created again, the group associated with hackers now. And the Edward created again, but the group associated with hackers now. So that is because we have set the SGID bit, and whoever the user is creating the content within the directory vulnerabilities directory that directory will automatically have the same group ownership as the directory itself. So that's all about the SGID bit. And now let's go pop over to my notes again and take a look at the set user ID. So let's talk about the set user ID bit, or the SUID, or the SUID we call. So SUID bit has the numerical value of 4000. For the UGO it has S, so similar to the set group ID here. And example permission would be 4644. And for example, we have like 4000, which is the set user ID bit plus 644 is equal to 4644. The set user ID bit is a special permission in Linux that allows a file to be executed with the permission of its owner rather than the user who ran in the file. So let's take a look into my virtual machine. I want to give you an example of changing the password of a low-level user, maybe Edward in this case. So switch user to Edward. And when we want to change the password, we type the PSSWD and the name Edward. So when we hit enter, what it's going to do is it's going to check the file called the etc password. So etc password is a file that stores the basic information about the system users, like their username, user ID, home directory, shell, and etc. So why the program checks that etc password file? It checks to make sure that the user actually exists or not. So when we enter like Alan, so it says Alan do not exist because it has already checked the file etc password. So we can cat that etc password file to see how it look like. So we have multiple users, Robin, Edward, and Stephen. We typed Alan, and it says the user doesn't exist. So we can see because the program has checked the etc password file and didn't see any user called Alan. So when we change the password of Edward himself, when we hit enter, and the current password would be, and the new password would be, I'm going to type it. Okay, so now we have the password updated successfully. So that's very important. That stage is very important. Password updated successfully. So we have successfully changed the password of the user Edward, who is also the low-level user. So it was updated. So you might have some question that updated to where. So it was updated to the etc shadow file. So etc shadow file, it stores the encrypted or the hashed passwords and the password policies. Access into this file is highly restricted, and it's owned by the root user and only accessible by the processes running with the root privileges. So that's very sensitive and very popular file. So there might be one question, that why are we able to access that file without the root privilege? We had access to the highly restricted file. So we have modified or overwritten the old hash with the new one. So we can see from the root user cat etc shadow. So we can see here, these are the hashes. These are the hashes. These are encrypted. These are the password of that user Edward. So we have updated that one. So you can analyze by yourself the difference between the two hash before updating the password and after updating the password in your machine. You can analyze it by yourself. So what we have the access to the highly restricted file, in this case etc shadow file, from the low level user. So that's so weird. So why are we able to access the highly restricted etc shadow file from the low level user? So how did we get the root privilege? So that's a big question. Because there's only one answer, because we have the SUID bit. With the help of the SUID bit, we had the access to that etc shadow file. So by all means, we got the root privilege. So with the help of the SUID bit. So when we see ls-HAL user bin PSSW, now we're looking at the PSSW command, and we can see RWS. Instead of X, we have S. That means Kali has set that SUID bit by default to the PSSWD system binary. That's why we are having the root privilege by using that PSSWD command, and we successfully modified or override the new hash for the user, for the low-level user Edward. So that's one scenario. Another one is going to be, this is the, now we're currently at the home directory of the root user /root. We can list out everything with the root user ls-HAL. So when we switch to Edward now, and so when we list out something, so it's permission denied, so it can't even CD. So when we CD to root, it can't even CD. So if you want to list things out of the home directory of the root user, maybe we can set the SUID bit to the ls command, so we'll be able to list things out with the root privilege. So let's do that. See, so let's look at ls-HAL to the user bin ls. We can see ln and rwx. We can make it rws. So it's going to be, it's now 755 755 755 and user bin ls. So we can set 4755 4000 plus 755. 4000 is SUID bit. So when we hit enter and take a look again, and now we have successfully set the SUID. So switch user to Edward back and bash -I, and when we list things out, now we're able to list out because we have got the root privilege. We have set the SUID bit successfully. So that's all about the Linux special permission, but you might be curious which directories or which system binaries has set the SUID bit or the sticky bit or the SCID. So I have one command, find, start from the very top of our file system, the user root, and perm of, for SUID we can set -4000. So when we hit enter, this is the list of all the system binaries that has the SUID bit set. So we can see it like grab password. So now we can see user bin password, and user bin password has set the SUID bit. So we can also see -1000 for the sticky bit. So these are the lists of the directories or the binaries that has the sticky bit set. We can also see 2000 for the SGID bit set, so we can see. And that's it for today's video on Linux special permissions. If you found this helpful, I'm happy to hear that. I'll also be uploading this video in Burmese soon, so thanks for watching and see you in the next one.